So we're going to focus and dedicate the next few videos to the idea of quadrilaterals. Now a quadrilateral is a four-sided polygon. Some common quadrilaterals are the square, which happens to be equilateral and equiangular because all the sides are congruent and all the angles are congruent. If you were to sit on a square, then the sides still remain the same, but the angles have switched a bit. So a square that's been sat on is called a rhombus, and a rhombus actually is equilateral but not equiangular. So the square is what we call a regular quadrilateral. Get used to using the words, right, in the right context. And then we have a rectangle, and the rectangle actually happens to be equiangular because all the angles are the same. However, the sides are not all congruent to each other. This pair is congruent to each other, and this pair is congruent to each other. So, for a rectangle, we can say that the rectangle is equiangular, but it is not equilateral. This is a kite, where these sides are congruent and these sides are congruent, but not all the sides are congruent to each other. So the kite is it's a quadrilateral that is not equilateral, not equiangular, and definitely not regular. Now these are convex quadrilaterals. We can draw, you've seen in the past, we can draw a quadrilateral that's concave. Right, here's 1, 2, 3, 4 sides. Right, something like an arrowhead, pretty much, is a concave quadrilateral. So let's say we have a quadrilateral A, B, C, D, and this happens to be something called a trapezoid. Well, we can say that angle A plus angle B plus angle C plus angle D is equal to 360 degrees. Now, a proof of this is going to be done in one of your assignments, and it's extremely important that you take notes on the proof. But let's look at one quick special example, right? Let's say we look at a square or a rectangle. Let's say we look at a square. And we know that a square has 4 angles, and those angles are all right angles. And a right angle is 90 degrees. So as one special case of a proof, if a square's got 4 angles and all of them are 90 degrees, well, if you add 90 plus 90 plus 90 plus 90, you're going to get 360. Now, we can't get away with that on something weird looking like this trapezoid. That's what the proof that we're going to do in the other assignment is all about. So just be aware, keep an eye on that proof, and take notes on it. Suffice it to say that any convex four-sided polygon, if you add up all 4 angles, it's equal to 360 degrees. Let's put this to work. So here we have a four-sided shape. We don't know what angle A is, so I'm going to call it X. So X plus, this is 90 degrees, plus 100 degrees, plus 95 degrees. It should be equal to 360 degrees. And if we combine these like terms, we get that. We subtract 285 from both sides. And our mystery angle happens to be 75 degrees. On a scale from 1 to 10 for this class, that was maybe a 3. Part B, on a scale from 1 to 10, this is more like an 8 or a 9. So this is a lot more difficult, more complicated. We note that this is again a four-sided polygon. So this is a quadrilateral. That means if I add up all 4 of these angles, it's equal to 360 degrees. This is what our setup looks like. If I combine all of the numbers on the left side, I get 227. If I combine the x values, I get 76x. If we subtract 227 from both sides, we get 133. If we divide both sides by 76, we get 1.75. No rounding. We're going to take it exactly the way it is. Now, this is the value of x, but the problem is not asking for the value of x. The problem is asking for us to find the 2 missing angles. Now, we know that D is 80 degrees. We know that angle B is 133 degrees. That was also given as well. A is this right here. And we know that x is 1.75. So for example, for angle A, if we were to go ahead and plug in that 1.75 in for x, we would get 71 degrees. Now finally, let's find angle C. Angle C is defined as 44x minus 1. If we replace the x with what we got before, 1.75, and do the math. And when I say that we do the math, I need to remind you about order of operations. Don't do 1.75 minus 1. We do 44 times 1.75, which is 77. And then we subtract the 1, and we get a 76 degrees. So angle C is 76 degrees. Now, you can always check, right? I mean, you could take all four of these angles and add them up. And I bet that if you do, it equals 360 degrees. That would be a good exercise for you to try on your own and to confirm what we did is correct. You are always encouraged to pause the videos, retry the problems on your own, and to make sure that you're getting the same results as I'm getting. You're also encouraged to write down words. I try to type some words for you, but I also say a lot of words verbally. I would suggest writing those words down, writing those explanations down to help you better understand this. For your summary, in problem 4, parts A and B, why were the angles added and set equal to 360? And please don't ignore the summaries. A lot of people ignore the summaries and then they're wondering why they don't have A's in the class. Because you lack understanding. Well, if you don't know how to do the summary, gain the understanding that you need. Reach out to me. Rewatch the videos. Try different things out. Do the summaries, please.